lesson, we looked at two more types of lines. We looked at parallel lines. Remember, parallel lines, parallel lines. They will never ever meet. And we also looked at perpendicular lines. Perpendicular lines were when a horizontal and a vertical line met to form a corner, and then the angle that was created, that means the turn between the horizontal and the vertical line that joined to make that corner, was a right angle, and we used that special symbol, that tiny square, to show that it was a right angle. So just to jog your memories and get you back thinking about parallel and perpendicular lines, how many pairs of parallel lines can you see, and how many examples of perpendicular lines can you see? Off you go. Well done if you spotted that the orange lines, they're parallel, they will never ever meet if we carried them on. Well done if you also spotted that the pink lines are parallel, and well done if you spotted that the green lines are parallel too. The rest of them, the light green, the red, the blue, the orange and the purple, they're all examples of perpendicular lines. Why? Because they show a horizontal line and a vertical line meeting at a point, and when they meet at a point, that makes a corner. It also makes an angle, and we call the angle the measure of the turn between the vertical and the horizontal line. When we show right angles, we draw a tiny square in the angle to show that it is a right angle. How many right angles are shown in each of the perpendicular line examples? Pause the video now while you have a look. Well done if you spotted that on the red line there is one example of a right angle. Can you see it's where this horizontal line joins this vertical line to make a corner, and that also makes an angle, and the angle is the measure of turn between the two lines. It makes a perfect square, and I've shown that using my green felt tip pen. There's the right angle. Well done if you spotted a right angle just here. Remember, this is how we show a right angle, by drawing in a square where the two lines, the horizontal and the vertical, join to make that corner and to make that right angle. Well done if you spotted a right angle just here. Are there any more on the orange? Yes, there's one on this side as well. So the orange lines are actually showing two right angles. Are there any other lines that are showing two right angles? Well done if you spotted the purple line. Here's one right angle. Here's the second right angle. And can you see the last one? How many right angles is this showing? Well done if you worked out four. There's one here, one here, one here, and one here. Did you know that every right angle actually measures 90 degrees? So every time we see an angle, we measure an angle in something called degrees, and every right angle is 90 degrees. So the distance between the horizontal and the vertical line is called 90 degrees when it makes a right angle. So this is 90 degrees, 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 this is 90 degrees. It's the measure of the turn between the horizontal and the vertical lines. We measure it in degrees, and a right angle is special because it's always a 90-degree angle. So in today's maths lesson, we are going to be identifying right angles, and we are going to be identifying angles that are smaller than right angles and angles that are bigger. To help us to do this, you are going to need to make one of these. It is your trusty right angle checker. As you can see, I have made it from some squared paper from my maths book, and I've cut carefully along the lines to make sure that it is entirely square. Why have I chosen to do that? Well, how many right angles does a square have? Oh, it has 1, 2, 3 and 4. So this right angle checker we can use to check whether a right angle is right rather than wrong, And we can use it to check whether angles are larger or smaller than a right angle. So pause the video now while you make yourself a trusty right angle checker. Then press play to find out how to use it to check whether angles really are right. Now you have your right angle checker. Checking whether angles are right is easy peasy lemon squeezy. What we're going to do is put the right angle checker, we're going to use the corner of it, which I know is a right angle. In fact, I'm going to use my felt tip pen to just show where that right angle is, just here. And then I'm going to place it in the corner to check whether it fits. So I can still see the vertical and the horizontal line, and it fits in the corner. It is a right angle. This is a good way to prove that right angles are right angles. I'm going to turn it around now and we're going to check this top one. We know it's a right angle. I'm just going to show you how to use it to check it. So the right angle checker goes into the corner, right into the corner. Can I see the horizontal? Yes, I can. Can I see the vertical? Yes, I can. It must be a right angle. So what if an angle is smaller than a right angle? How can we check that using our angle checker? If you have got a printer at home, you can print these sheets off from the PDF that I've put onto Dojo. If you haven't got a printer, don't worry. If you're working on a PC screen, you should be able to put your right angle checker to the PC screen to check. If you're working on a mobile or a tablet device, don't worry. If you just watch what I'm doing, then you'll be able to have a go a little bit later on. You might also be able to use your fantastic drawing skills to draw some of these angles and then use your angle checker to check whether it is a right angle or not. So I'm going to do the same thing as I did before. I've got my right angle checker. I know that every angle here is a right angle. So I'm going to go corner to corner. Can I still see the vertical and the horizontal line? Yes, I can. Is this a right angle? Yes, it is a right angle. So with my pen, I'm going to draw in my symbol to show it's a right angle. And I'm going to give it a tick and I'm going to put RA for right angle. Okay, let's have a look at this next angle. Just looking at it, I'm thinking it might not be a right angle. I'm going to use the corner of my right angle checker and I'm going to slide it in across that horizontal line. Oh, hang on. Can you see? I can't see a vertical line. You might be able to just see, I'll see if I can zoom in a little bit. Can you see that the line of the triangle, of the angle, is actually going up here? So is it smaller? Remember, our right angle should be here, shouldn't it? Because our square right angle checker shows the right angle. So if it was a right angle, we would have a dotted line or a line along here. Let me draw in where the right angle would be. Is this angle, because we've got our line, haven't we, that's on this angle coming this way, you might be able to just faintly see it over here. Is it bigger or is it smaller than a right angle? Well done if you said smaller. It is smaller because we can't see it, it's covered up. The right angle would be there, it's smaller. So it's not a right angle, it's less than a right angle. Now that's got a special name. If it's less than a right angle, we actually call this an acute angle. Now I really like to remember this name because I think, oh, it's less than a right angle. Oh, it's so cute. It's an acute angle. So think, oh, smaller than 90 degrees, smaller than a right angle. Oh, cute angle. Let's check this one. You could make a prediction. Do you think it's going to be a right angle? Do you think it's going to be less than a right angle? Let's use our right angle checker to see. So there's the corner. Here's the corner on my right angle checker. I'm going to slide it in line with that horizontal line. There it goes. Now, if it was a right angle, I would see a line just here. I'm going to pencil it in so that we can see. If I zoom in a little bit closer, you might be able to see the line of the angle just up here. So it's just there. You can see it slightly through the paper. So if I move that away so that you can see that there it is it bigger or is it smaller than a right angle? It is smaller than a right angle. So this is not a right angle. This is less than a right angle, which means that it is actually called an acute angle. Brilliant, because an acute angle is smaller than a right angle. It's less than 90 degrees. What if the angle is actually bigger than a right angle? How can we check with our right angle checker? We're going to do something very similar. We're going to take our right angle checker, slide it along the horizontal line until the corner meets the corner. Oh, now this looks different this time, doesn't it? Let me draw in where that right angle would be, because I can see that my right angle checker finishes just here. So I'll dot in that line where the right angle would be, but our angle, our vertical line doesn't go there. It isn't a vertical line. Where does it end up? It ends up over here. So is it bigger or smaller than a right angle? Well done if you said bigger than a right angle. So this is not a right angle, it is bigger than a right angle. Excellent. Let's have a look at this one next. Make a prediction. Do you think it's going to be bigger or smaller than a right angle, or could it be a right angle? What do you think? Now take your right angle checker and let's check. So we're going to slide it along the horizontal until it meets the corner. Hang on a minute. I think we can tell already. I'll dot in where that right angle would be if it was a right angle. That vertical line would be there if it was a right angle, but it's not, is it? This line's over here. So is that more than a right angle or less than a right angle? Well done if you said bigger than a right angle. So it's not a right angle, it is bigger than a right angle. Right, let's have a final look at this one over here. Prediction time. What do you think? Is it smaller than a right angle, or bigger than a right angle? Right, let's take in the right angle checker. Slide it in along that horizontal till it meets the corner. Oh, look at that. What kind of angle is this? Well done if you said it is a right angle. It is a right angle. And we could see that our right angle checker fitted right inside, and we could see the vertical and the horizontal. So when we have an angle that is bigger than a right angle, we call it an obtuse angle. So let's practice showing a right angle. I've just got 2 strips of paper, and I have actually got a pin that I've just poked through to hold them together. You don't need a pin, you can just do this with your hands. So if you overlap the paper, you can show a right angle. Then show an angle that's smaller than a right angle. I'll move it to here. This now is smaller than a right angle. I can check it using my right angle checker. Oh look, if I put that there, it is smaller than a right angle. If I open it, that means it's an acute angle. If I open it up to a right angle again, I can now show an angle that's bigger than a right angle. This is an obtuse angle. So we've got right, acute, obtuse. There's a right angle. If I move it a tiny bit like that, it's still an obtuse angle. It's still bigger than a right angle. If I have it back at a right angle and I bend it like this, all of those angles, all of those places are acute angles. So I'm going to show you the angle. You're going to tell me, is it right, acute, or obtuse? So let's have a go. What's this? Right angle. What's this? Acute angle. Obtuse angle. What's that one? Still an obtuse angle. What's this one? Right angle. What's this one? Acute angle. this one? Obtuse angle, what's this one? Right angle, what's this one? Acute angle, what's this one? Still an acute angle, it's not at 90 degrees yet, it's not a fully horizontal and vertical line joining together. What's this one? Right angle, well done. So I've got a fun way to remember these, and it's through a bit of a song. So you'll pick up the words really quickly and then you can join in with me. Right angles, they are 90 degrees, I said acute angles. Less than 90 degrees, I said obtuse angles. More than 90 degrees and a straight line is 180. Right angles, they are 90 degrees, I said acute angles. Less than 90 degrees, I said obtuse angles. More than 90 degrees and a straight line is 180. The angles are right, acute, obtuse. The angles are right, acute, obtuse. So on task 3, it asks you to use your right angle checker to check some angles inside different shapes. Now to do this, I'm going to just model to you on the computer in case you're using the computer because you don't have a printer. So for this rectangle, what we'd want you to do is to draw it out in your book and then to check whether it had angles that were a right angle or not. So as you can see, I'm placing my right angle checker on the screen. Is it a right angle? Yes, it is. Now it tells me on the key that right angles must be coloured in green. So I'm going to colour in that angle green. And I'm going to check the next angle down here. Is it a right angle? Yes, it is. So I'm going to colour that angle in green. I'm then going to go to the next angle. Is it a right angle? Yes, it is. I'm going to colour it in green. And then finally, check the last angle. Is it a right angle? Yes, it is. I'll colour it in green. Then you're ready to move on to the next one. So what you might want to do for this is, if you are on a computer screen, you'll find it a bit more tricky. But if you've got it on paper, turn the paper as you go so that you can deal with each angle in turn. So I'm going to go for this corner now. I'm going to line it up along this edge. So I've chosen one edge. I've got the corner of my right angle checker just there. Now, is that a right angle? Is that line that joins to make that corner, is it along here where the right angle would be? No, it isn't. Is it below or is it above the right angle? Well done if you said it's above. It is. It's over here, isn't it, instead of here or below there. So this is an obtuse angle. It's bigger than a right angle, so I colour it in blue. I'm then going to move around and check the next one. So I'm lining up one of the lines with the line on my right angle checker, making sure the corners match. Now if it was a right angle, the second line that joins to it would be coming down here. Is it? No, it isn't, is it? It's actually going over there. So is that bigger or smaller than where the right angle would be? Well done if you said it's bigger. It is bigger, so it's an obtuse angle, so we colour it in blue. And then you carry on around the rest, and then you move on to the next shapes. Okay, so that's kind of what you need to do on task 3. After you've checked and worked out whether the angle is right, acute, obtuse, then what I'd like you to do is try the challenge, which is to think about how you could group those shapes. Perhaps you could group all of the shapes that only have right angles. Perhaps you could then have a group of shapes that maybe had one right angle. Perhaps you could make a group of shapes that had 2 right angles. Maybe you could do all of the shapes that have got only right angles, all of the shapes that have only got obtuse angles, all of the shapes that have only got acute angles, and then maybe any mixed shapes if they've got a mixture of right, acute, obtuse angles inside the shape. And then the final task is an optional task for those of you that are working quite quickly through this, that really understand this and want to challenge and push yourself further. So the letter A has 3 acute angles and 2 obtuse angles. Fact. Can you label the angles using a colour and a key? Then what I'd like you to do is to investigate how many different angles you can spot in the word angle and record your findings in a tally table just like the one that's here. Does your name contain more or less acute angles than the word angle. That's something for you to really get your teeth into if you are enjoying this work and want to push yourself further, or if you are interested in finding out. It'll be great to see what you discover. Good luck!